All right, this is the quiz from Friday, January 30th. It's the AP Pre-Calc quiz. If you took it, I hope you crushed it. If you haven't taken it yet, look at the description of the video. You can find the quiz there with the solutions. All right, so here's our free response quiz. Question 1 is right here. I'm just going to scroll down here to give myself some more room. It says evaluate the expression given. And so part A, it's sine of alpha plus beta. Now they give us some information about the angles alpha and the angles beta. So what we need to know on our end is how to expand the sine of alpha plus beta. So this past week we learned the formula for this, that the sine of alpha plus beta is equal to the sine of alpha times the cosine of beta plus the sine of beta times the cosine of alpha. So we have to figure out what each of these values are. In the directions here, it says sine of alpha is 3/4. So I'm going to replace the sine of alpha with 3/4. It says here in the directions that cosine of beta equals 1/2. So I'm going to use direct substitution and plug in 1/2 here for cosine of beta. Now the next part requires a little bit of work. This says sine of beta, and beta is in between 0 and pi over 2. We know if cosine of beta outputs positive of 1/2, the angle beta must be in the first or fourth quadrant because the cosine of the angle is positive. So this is getting really specific, saying that beta is between 0 and pi over 2. Now, I would love it if you recognize beta as the angle pi over 3. It's like, how do we know that? Because we're familiar with the points in the unit circle that have an x-coordinate, cosine x-coordinate of 1/2, which is right here. This point is 1/2, comma, the square root of 3 over 2. So where it says sine of beta right here in our formula, we're going to replace that with the square root of 3 over 2. Cosine of alpha. Now I see sine of alpha is 3/4. I'm not familiar with that value on the unit circle. So I would prefer if I just draw an angle, alpha, and alpha has to be between pi over 2 and pi. So I'm going to sketch the angle right here of alpha. This is pi over 2. If we start at 0, that's pi over 2. Here's pi. Alpha's got to be somewhere in between pi over 2 and pi, so I'll just draw it there. And I'm going to draw, we'll call this angle here our reference angle alpha. The sine of alpha, SOHCAHTOA, right? The sine of alpha is the opposite over the hypotenuse. So this opposite side is 3, the hypotenuse is 4. Now I'm going to find that missing side, I'll call it x. So using the Pythagorean theorem, x squared plus 3 squared has to equal 4 squared. So x squared equals 7. I took 4 squared is 16 minus this 9. 16 minus 9 is 7. Take the square root of both sides, we get plus and minus the square root of 7. Now, if I am at the origin, I'm going to go to the left. So that's going to be a negative square root of 7. This point here in pink would be negative rad 7, comma 3. Now, it says here the cosine of alpha. So going back to our SOHCAHTOA, the cosine of alpha, given a right triangle, is the adjacent side, negative rad 7. over the hypotenuse of 4. Notice this is alpha and that's alpha. Sine of alpha, this 4 here should be the hypotenuse. This 4 here is also hypotenuse. That matches up. If we look at it as opposite over hypotenuse and adjacent over hypotenuse. Alrighty. We should also know that this angle alpha is in the second quadrant, and cosine of those angles, second quadrant, should be negative. Now I'm just going to simplify this. 3 times 1, that's 3 over 8. Square root of 3 times negative square root of 7. That's negative square root of 21 over 8. So that's our final answer. You can write that as 3 minus the square root of 21 over 8 if you want to. Either of these, full credit. All right, now let's do part B. So the cosine of alpha plus beta. We have to know that this is equivalent to the cosine of alpha times the cosine of beta minus sine of alpha times sine of beta. Now this should be really quick because based on the previous problem, we have all these values already. Sine of alpha is 3/4, that's given. So this is 3/4 here. The cosine of beta is 1/2. Now the cosine of alpha, I drew this triangle we figured out a moment ago. Here, cosine of alpha is negative square root of 7 over 4. And the sine of beta, we figured out was the square root of 3 over 2. So this is negative rad 7 minus 3 rad 3 all over our common denominator of 8. That's the answer to 1B. All right, 1C, establish this identity here. So this is a true statement. It's not saying if this is true, it's for sure true. Our job is to show that this is true. So I'm going to choose the left-hand side. So I'm going to write LHS. I'm just going to rewrite what I have on the left-hand side. So step 1 when solving these puzzles here is to pick a side. You can pick the left side or the right side. Now, before I begin, the first thing you should think about, my little thought bubble here, is where am I trying to go? What do I want this to become? I want this to condense to 2 times secant of x. And so I'm thinking, oh, what is secant? Secant is the reciprocal of cosine. So I'm seeing or thinking 2 over cosine of x. So see this cosine of x? I love that that's cosine of x. I want that to be cosine of x because this right here has a denominator of cosine of x. So I want to keep this fraction alone. This guy here is bugging. The second term here, this denominator is 1 minus sine x. We don't want that. We want this to have a denominator of cosine of x. So I have 2 options. My preference is to force this denominator right here to be cosine of x by multiplying the numerator and denominator by cosine of x. I have complete confidence that these 2 denominators should eventually just be cosine of x. So I'm confident that this 1 minus sine of x is going to go away. It's going to cancel. You're going to see that played out in just a moment. So the reason why I put this cosine of x here, let me put it in dark blue in case that's not showing up on your screen. I put this here because that's what I want to get these denominators to become. Boy, it'd kind of be nasty if people did combine these and create a common d. I don't really want to do that, but you could try that. So here, cosine of x times cosine of x is cosine squared x. So I'm going to rewrite this first term as 1 minus sine x over cosine x plus cosine x times cosine x is cosine squared x. Now again, I don't want to spend the time distributing this cosine of x down here in the denominator. Why? Because I'm confident that this 1 minus sine of x is going to cancel, because I need to have cosine of x in my denominator. So when you see a trig function squared, you should be thinking about your three Pythagorean identities. So I'm going to abbreviate PI for Pythagorean identities. We know that cosine squared of x plus sine squared of x is equal to 1. So see this cosine squared x? I'm going to replace it, use substitution. So I want to solve this equation for cosine squared x. So that's cosine squared x equals 1 minus sine squared x. So right here, this cosine squared x is going to get replaced with this 1 minus sine squared x. Why? Because I want this 1 minus sine x to cancel, and it's going to in just a moment. So I'm going to rewrite this first term again. It's just kind of chilling here. This orange highlighted cosine squared x is equivalent to 1 minus sine squared x. And I still have this times cosine of x down here. Now when I see this, I think of three words. Difference, because of the minus sign, of squares. 1 times 1 is 1. Sine x times sine of x is sine squared x. Difference of squares factors to conjugates. Like, what does that mean? It means this. You know when you have 4 minus x squared? That's a difference of squares. It's an example. This factors to conjugates. 2 plus x and 2 minus x. This is what I'm seeing. I'm seeing difference of squares when I see this, knowing that this will factor to conjugates, kind of like that. So I leave this first term right like it is. I know I factor 1 minus sine squared x as 1 plus sine x times 1 minus sine x all over. I still have this denominator here. But here's what's really cool. The factors are separated by multiplication. So I have 1 plus sine x times 1 minus sine x. So I have the word times right here. So 1 plus sine x is a factor and 1 minus sine x is a factor. Here I have 1 minus sine x in parentheses times cosine of x. So these are both factors as well. You can only cancel factors when you're simplifying. So this 1 minus sine x factor matches, it's the same as this factor in the denominator. So I can cancel common factors. That's beautiful because now I have what I've always wanted. I was thinking, hey, we have to get this to become 2 over cosine of x. And I'll worry about the 2 in a moment, but I got what I wanted, cosine of x here. So just so this is super clear, I'm going to spend a step just to rewrite what we have. We have a common denominator of cosine of x. So I can add these fractions and keep that denominator. I'm going to combine the terms in the numerator. 1 plus 1 is 2. Negative sine x plus sine of x is 0. And this is exactly where I wanted to be. 2 over cosine of x, which equals the right-hand side, 2 times the secant of x. That's perfect. That's what we wanted. So I just showed that the left-hand side is equal to the right-hand side. So you pick a side and you rewrite it to get it to equal the other side. Now, there's multiple ways of doing this problem. If you wanted to, you could multiply here in this first step. Instead of the blue cosine of x over cosine of x, you can multiply by 1 plus sine x over 1 plus sine x. And that would give you 1 minus sine squared x in the denominator. And you could replace that 1 minus sine squared x with cosine squared x. That would be fine if you multiply by 1 plus sine x over 1 plus sine x, and you'll get the same answer. All right. Question 3. So this is more like the College Board. They'll give you an expression, and they'll tell you like, hey, the answer should be the cotangent of x, or it should be the tangent of x. Rewrite this expression. My directions are a little more vague, but similar. It says simplify the expression, and it says the solution will either be a numerical value, so a number, or a trigonometric function, so a trig function. Since the College Board is really specific and they say rewrite it as a tangent function, then you'd have to have tangent. For my questions here, we might have 2 different possible answers for each one that would be correct, and we'll talk about that right now. So 3a. I look at 1 plus tangent squared x, and I remember that's one of our Pythagorean identities. I'll derive this one. If we remember that sine squared x plus cosine squared x equals 1, if we divide each of these terms, we divide both sides by cosine squared x, I have to distribute this division. I have to divide this into each of these terms. So sine squared x divided by cosine squared x. I'm going to write that right here. Plus cosine squared x divided by cosine squared x. So I'm distributing this cosine squared x, just like multiplication, but I'm dividing into each of these terms, equals 1 over cosine squared x. I'm going to write that as secant squared x. Sine squared over cosine squared, that'll be the tangent squared function. Cosine squared x over cosine squared x is 1. So that's how I derive this Pythagorean identity. Now look here. See how I have 1 plus tangent squared x, 1 plus tangent squared x. I can replace that with what it's equal to. It's equal to secant squared x. So I'm going to go ahead and rewrite part A. I'm going to replace 1 plus tangent squared x with secant squared x over tangent squared x. Now I'm going to rewrite this as 1 over cosine squared x. That's what secant squared x is equal to. Secant squared x is the reciprocal of cosine squared x. Now tangent squared x, I'm going to write this as times cotangent squared x. So 1 over tangent squared x is equal to cotangent squared x. So to be clear, the secant squared x is equal to 1 over cosine squared x, and 1 over tangent squared x is equal to cotangent squared x. I'm going to change or rewrite cotangent squared x as the cosine squared of x over sine squared of x. Now again, cosine squared x is a factor of the numerator and denominator, so I can cancel those. All right, so if this was a College Board question, it would likely say rewrite this expression as the sine of x, and this would be your answer. Or it might say rewrite this expression as the cosecant of x, and our answer would be cosecant squared of x. So 1 over sine squared of x is equal to cosecant squared of x. So I will accept either of these answers because the directions say to write it as a numerical value or a trig function. So to me, either of these is full credit. All right, part B. So we have sine of x times cosine of x over 1 minus cosine squared x. So I hope when you see 1 minus cosine squared x that you recognize that. Going up to our Pythagorean identity here, if you see in highlighted blue here is cosine squared x equals 1. If I were to subtract cosine squared x to both sides, we get sine squared x equals 1 minus cosine squared x. So I'm going to replace 1 minus cosine squared x with sine squared x. So in the numerator, I have sine of x, that's one of the factors, times the other factor, cosine of x. In the denominator, I have sine of x twice. Sine of x is being squared. So I'm going to cancel one of those sine of x factors, and I get cosine of x over sine of x. Now this is equal to the cotangent of x. So if this was on the College Board exam and it said rewrite this expression as cotangent of x, that'd be our answer. The College Board says rewrite this expression as tangent of x, it'd be 1 over tangent of x. Based on my directions, to write it as either a numerical value, which it won't be in this one, or a trig function, I'll accept either of these two answers for full credit. Number 4. Now we've seen this problem on the last 3 or 4 quizzes, but it was a minus sign here, and we didn't have any issues with that using the quotient property for logs. It was after we took the inverse of both sides where we had trouble solving for x. So this week's it's slightly different. We have the addition of these two logarithms, both with base e, so we're able to condense them using the product rule. So it's natural log of x times x minus 2 equals 4. Now, to solve, or to undo, I should say, this natural log right here, we have to use the inverse function, which is base e, the exponential with base e. So I'll take base e of the left side and get x times x minus 2. I'll take base e of the right side and get e raised to the 4th power. Now I can see here, if I distribute the x, I get x squared minus 2x equals e to the 4th. Now I have two options here. I could subtract e to the 4th and use the quadratic formula, which I usually do if it was like a problem like this. But I notice that this middle coefficient is even, and we have a leading coefficient of 1. So what does that mean? I want to complete the square to solve this. That's my preference. So I'm going to add 1 to the left side of the equation and add 1 to the right. That's how we complete the square. I got the plus 1 by taking half of negative 2, that's negative 1. And you square negative 1, you get plus 1. So now I know that these 3 terms will factor to a perfect square. That's why it's called completing the square. It'll be x minus 1 times x minus 1. But I'm going to write that instead as x minus 1 squared equals e to the 4th plus 1. Now I'm going to take the square root of both sides of the equation. Now it might be really tempting to take the square root of e to the 4th and then also take the square root of 1, but you're not allowed to do that. That's illegal. You can only take the square root if this is the product of 2 numbers here. I cannot rewrite this, so I'm going to leave that alone. I'm going to add 1 to both sides of the equation. Now we have one little issue. It looks like I have 2 solutions. These are actually both solutions to these steps of the equation, but not the initial one. Let me explain. The natural log of a negative is undefined. So x cannot be negative. Let's say x is negative 1. If I plug in negative 1 here, natural log of negative 1 is undefined. If I plug in negative 1 here, natural log of negative 3 would be undefined. But in the next step, since I condense them, I have the product. If x is negative 1, this would be negative 1 this become -3. And a negative times a negative would become a positive. So then when I take the natural log of a positive, it's all good. So long story, well, too late, but long story short, 1 minus the square root of e to the fourth plus 1 would be a negative number. And I would not be allowed to plug it in right here. Well, I would. And the natural log of that negative would be undefined. So it would not be a solution to the equation. So I must exclude that answer and say the only answer to this equation up here is 1 plus the square root of e to the fourth plus 1. All right, question 5. We're graphing, so these are review of graphing trig functions. So we should know that the secant of 0 is 1 because we know the cosine of 0 is 1, and secant is the reciprocal of cosine. So I'm going to put a point here and draw my curve like this, and this is 1. We should know that the cosine of pi over 2 is 0, and since the secant of pi over 2 is just reciprocal of cosine, it'll be undefined. So there's going to be a vertical asymptote there. Oops. Okay, so that's 1.5 periods. This will be 2 periods. If we go back with the directions, it says when graphing trigonometric functions, graph at least 2 periods of the function. Label the intercepts, asymptotes, and the relative max and minimum values on the y-axis. So I've already labeled the relative min of 1 on the y-axis and the relative max of -1 on the y-axis. Now I have 2 periods drawn there. If you remember, for cosine, secant of x, this asymptote is normally pi over 2. But I have to apply this horizontal compression or horizontal shrink. We have to not multiply all the previous or original inputs by pi, but divide by pi. So pi over 2 divided by pi will become 1/2. This asymptote for secant of x is normally 3 pi over 2. Well, it is 3 pi over 2. Divide by pi. Now it's 3/2. This is usually 5/2 pi. Divide by pi, now it's 5/2. This is normally negative pi over 2 divided by pi is -1/2, and this is -3/2. Little review, the period of secant is the absolute value of 2 pi divided by pi, which would be 2. The asymptotes are half a period apart. So 1/2 of the period is equal to 1/2 of 2, which is 1. So let's check this out. See how this is 1/2, and that's 3/2? Or let me say it as this way, 0.5 and 1.5. This is 1 unit, 1 away from each other. That's half the period. If you weren't sure that this was a half, from this asymptote to this asymptote is a half of the period, which is a value of 1. So this is 1 here. That's half of 1. This is the other half. So notice that each asymptote is 1 unit away from the next one. Okay. Let's graph 5b. My preference would be to look at the amplitude or this output stretch of the cosine function of 3. So I'm going to label my relative min and max on the y-axis by labeling this 3 and labeling this -3. Now, my preference is to find the y-intercept first by plugging in 0 for x. So to find the y-intercept, you know x is 0. So we plug in 0 for x. And we get the cosine of negative pi over 2. The cosine of negative pi over 2 is 0. Times 3 is 0. So this intercept is here. Now the period of this function is the absolute value of 2 pi divided by this coefficient of x. That's pi. That means 1/2 of the period is equal to pi over 2. Why is that important? Because just like secant, an asymptote to asymptote was half a period apart. And that will be true for cosine. It's as long as we don't shift the graph up or down, that'll be true for cosine as well, but not asymptotes, but x-intercepts. The x-intercepts are half a period apart. So if we have an x-intercept at the origin, and the next one has to be over here at pi over 2. This one will be at 2 pi over 2, or pi. From 0, 0, I go left pi over 2. Go left pi over 2 again, I get negative pi. So those are my x-intercepts for this function. If you wanted to, you could graph 3 cosine of 2x first, and then apply the shift, which would be right pi over 4. If you set this equal to 0 and solve for x, you get x equals positive pi over 4. I prefer this method here instead for this problem. Now, the thing I'm not sure about right now is starting at 0, 0, is the function increasing initially, or is it decreasing? Boy, I would have loved it if it was like the last quiz, and if the y-intercept was up here at the relative max, then I know for sure it has to decrease as I go to the right. Or like the other problem in the quiz, if the y-intercept was down here, then I know it has to be increasing. But because it's at the origin, I'm not sure if I'm going up or going down. So what I'm going to do is I'm going to look in between 0 and pi over 2. Right in the middle of that, I should have either relative max at 3 or relative min at negative 3. So I'm going to plug in pi over 4 in the equation, expecting an output of 3 or negative 3. So let's do that. I'm going to let x equal pi over 4. I get 3 cosine. So I plug in pi over 4 here. 2 times pi over 4 is pi over 2. Minus that pi over 2. Okay, great. So pi over 2 minus pi over 2 is 0. The cosine of 0 is 1. So 3 times 1 is 3. So as expected, I was expecting either relative min or relative max. It's going to be a relative max right here. And now I can sketch the rest of my graph with confidence. It's going up here, and then down. Down and then back up. That's a full period. See how we said the period equals pi? So from this point here on the x-axis, all the way to here is pi. I'm going to sketch this part as well. And that's 5b. Okay, 5c. We're shifting the cotangent of x graph to the right 5 units. We should know that the tangent of 0. We should know that the tangent of 0 is 0. So the angle is 0. The tangent of 0, which is the slope of that angle, is 0. So the cotangent of 0 will be undefined. So cotangent has a vertical asymptote on the y-axis. And the period for cotangent is actually the absolute value of pi, not 2 pi, but pi, divided by the coefficient of x. So that's pi over 1, which is pi. And unlike secant and cosecant, asymptote to asymptote's a full period for cotangent and tangent. Okay. I don't need to graph too much of this. This is already 2 periods. In between 0 and pi is pi over 2. I don't really need to look at that, to be honest with you, and I don't think you need to either. What you need to know is that cotangent of x has a vertical asymptote at the y-axis. And now we're shifting the whole entire graph of cotangent of x to the right 5/4 pi. So see this asymptote here? It's going to go all the way over 5/4 pi, but notice that's more than a period. The period of this is still 1 pi because the coefficient of x is still 1. So I'm going to shift the vertical asymptote that used to be on the y-axis over the right 5/4 pi. But you should know that there's another asymptote pi apart. So it'll actually be right here. There's one more to the right of the y-axis. So if I take away pi from 5 power 4, I get 1 pi over 4. So pi over 4 and 5 power 4 are pi apart. If I go left, pi again, I get negative 3 pi over 4. This is our curve here. This is our curve. So there aren't any relative max or mins for this function. I don't need to label anything on the y-axis. I just need to find these x-intercepts. Now these x-intercepts are also a period apart. So if I can find one of them, I know the other one is just a period or a pi apart for this problem. So this x-intercept is in the middle of these two asymptotes. This x-intercept's in the middle of these two. So what I could do is I could find the average, the middle number of these two values. So pi over 4 plus 5 pi over 4, let me write that down. So that point in blue, we're going to take pi over 4 plus 5 pi over 4. Now that one could be the average, that's just the sum of those. So you have to divide by 2, which is the same thing as multiplying by a half. So pi over 4 plus 5 pi over 4 is 6 pi over 4. That reduces to 3 pi over 2. Multiply by 1/2. 3 pi over 2 times a half is 3 pi over 4. Okay. Asymptote to x-intercept, as long as we're not shifting the graph up or down, should be half a period apart. So if the period is pi, half of that is pi over 2. So, oh yeah, okay. So instead of doing this average right here, I could have just said, look, I'm going to go half a pi to the right. So if I add 2/4 pi, 2/4 pi is a half a pi, I get 3/4 pi. Add 2 pi over 4 to this, I get 5/4 pi. I could take the average of these two values to find that point. Or I could go pi to the left from 3 pi over 4. That'd be negative pi over 4. Or from this asymptote to that x-intercept is 2 pi over 4. And the distance between here and here should also be 2 pi over 4. So there's multiple ways of doing this. Now I'm seeing this y-intercept here. It should be negative. So I'm going to plug in 0 for x to find that. So I need to figure out the cotangent of negative 5 pi over 4. So I'm going to sketch the angle negative 5 pi over 4. It's going to be in the second quadrant. So I'm going negative 5 pi over 4. The tangent, I know that says cotangent. Tangent's reciprocal. But the tangent of this angle is negative 1. So if I take the reciprocal of negative 1 to find cotangent, it's still negative 1. So that's what that y-intercept will be. All right, question 6a. So we're evaluating the composition of these functions here, the sine of the arctangent. Now, we should be familiar with the fact that rad 3 over 3 is the same value but looks different as 1 over rad 3. So my students are more familiar with 1 over rad 3 as being the slope of the angle pi over 6. So square root of 3 over 3 is the slope of the angle of pi over 6. So when I look at this, I see arctangent. This represents the slope. You actually don't need to know what this angle is called. There's technically, I'll make this dark blue in case you can't see it. There's technically another angle over here in the third quadrant that has the same slope as this one in the first quadrant. But we have to know that arctangent has to put an angle between negative pi over 2 and positive pi over 2. And this says, what's the sine of that angle? What's the sine of that blue angle? Well, that would be the y-coordinate. This point is rad 3 over 2, comma 1/2. So the sine of this angle, which is technically pi over 6, will be 1/2. All right, you need to look at this part B and realize that that's the angle addition for sine. Sine of an angle times cosine of an angle plus sine of an angle times cosine of an angle. That's going to be angle addition for sine. See the pi over 12 here, pi over 12 there. Okay, great. So I'm going to condense this as the sine of pi over 12 plus 5 pi over 12. That's equal to the sine of 6 pi over 12, which equals the sine of pi over 2. So I'm going to draw the angle pi over 2. It's right here. This point where the angle intersects unit circle is 0, 1. So the sine of this angle is that y-coordinate. So the answer is 1. Part C. Arc cosine of 2/3. So arc cosine is going to be an angle. And then we're going to take the sine of that angle. Now, I'm not familiar with, since this says arc cosine, this would be an x-coordinate in the unit circle of 2/3. I'm not familiar with that angle. So my preference will just be to draw the angle on a triangle and then evaluate what the sine of that angle is. So we should know that arc cosine has to output an angle in the first or second quadrant. And since this is positive 2/3, it would have to be the angle in the first quadrant. Just to understand this, I'm going to let arc cosine, the inverse trig functions, output angles. So I'm going to let this be an angle. I'm going to put theta here. This implies that the cosine of theta will equal 2/3. So I'm going to call cosine of theta, here's our triangle. This will be the adjacent over the hypotenuse. So adjacent side over the hypotenuse. I'm going to use the Pythagorean theorem to figure out this missing side. 3 squared is 9. 2 squared is 4. 9 minus 4 is 5. This will be rad 5. It's not going to be negative rad 5 because I'm going up. Now this says, what's the sine of this angle theta? So it's the opposite over the hypotenuse. The answer is rad 5, or the square root of 5, divided by 3. Part D. Cosine of an angle times cosine of an angle plus sine of an angle times sine of an angle. And I'm looking at the angles that are being used here. Okay, great. Now this appears to be the angle addition for cosine. And I wrote that formula down in the first problem. But actually that's normally a minus sign there for the angle addition of cosine. So this problem will actually condense to the cosine of 7 pi over 12 minus pi over 12. If this was a minus sign here, knowing the formula for angle addition of cosine, then this would be a plus, but it's not. That's a plus, so this is a minus. this is equal to the cosine of 6 pi over 12. That reduces to the cosine of pi over 2. We have the angle pi over 2 already drawn up here. Cosine of that angle is the x-coordinate, which is 0. Part E. Cosine of this angle is going to be an x-coordinate where the angle intersects unit circle. The arc cosine will be an angle, but it has to be in between 0 and pi because we're familiar with our outputs for arc cosine. Technically, arc cosine could be 0 and also pi, but we're expecting a value between 0 and pi. I can't just say these undo each other and the answer is negative 2 pi over 3 because negative 2 pi over 3 is not between 0 and pi. So let's first look at the cosine of negative 2 pi over 3. That angle is right here. This point is negative 1/2 common negative square root of 3 over 2. So technically, the cosine of negative 2 pi over 3 is going to be this x-coordinate where the angle intersects unit circle. So that's negative 1/2. Now I have this question. Arc cosine of negative 1/2. Right here is the other location on the unit circle where there's a point with an x-coordinate negative 1/2. And this angle in blue, I need the answer to be between 0 and pi. So it's actually going to be this angle here is our answer. All right, part F. I'll write it down here. We have the secant of the arc tangent of 1/3. Now, this is arc tangent, so 1/3 represents the slope, the rise over run, the opposite over adjacent of the angle that arc tangent outputs. Now, I'm not familiar with that slope, meaning this answer, this output is not an angle, it's a multiple of pi over 6 or pi over 4. So I'm going to need to draw the triangle. Now, arc tangent of 1/3. Arc tangent has to output an angle between negative pi over 2 and positive pi over 2. So because that's a 1/3, a positive slope, the angle will be in the first quadrant. Rising 1, running 3. I'm going to draw a right triangle here. I'm going to call this theta. That means the tangent of this angle theta is equal to 1/3. So tangent of theta given a right triangle is the opposite over adjacent, the opposite side over the adjacent. I want to know what secant is. That's the reciprocal. The secant of this angle is the reciprocal of cosine. So I'm going to need to know what the hypotenuse is. So I'll use the Pythagorean theorem. 3 squared plus 1 squared. Well, that's 9 plus 1 is 10. So this is the square root of 10. So the cosine of theta is equal to the adjacent side divided by the hypotenuse. That would imply the secant is the same thing as the reciprocal of cosine. So I'm going to take the reciprocal of 3 over rad 10 and I get rad 10 over 3. Okay, part G. Now, arc tangent is the inverse of tangent. So you might be thinking, hey, the answer is 3/4 pi, we're done. Not quite. Arc tangent, like I said a moment ago, has to output an angle between negative pi over 2 and pi over 2. So 3 pi over 4 are out of those bounds, or it's out of the bounds there. So it can't be it. Let's just focus on tangent of 3 pi over 4 first. I'm familiar with that angle. I can draw a unit circle here. 3/4 pi is right here. The tangent of 3 pi over 4 is going to be -1. The slope of this angle is -1. Now, evaluating arctangent -1, you have to draw all of the angles that have a slope of -1. So there's also angles in the fourth quadrant. The tangent of 7 pi over 4 is -1. The tangent of negative pi over 4 is -1. Arctangent has to output an angle in between negative pi over 2 to positive pi over 2. So 7 pi over 4 would be out of the bounds. I can only go this far here. So the answer has to be negative pi over 4. Alrighty, I hope this video helps you to understand any of the questions that you got wrong or you didn't quite understand, and I hope you do great or even better on the next quiz. Thanks for watching.